just went to total full screen with that.
There,
So,
that's it.
Super. Okay, well, here we go. Fasten your seatbelts. What's a ZTF? We're going to try to answer these three questions in a few minutes. Can I see it, and can I get a picture of it? Okay. And let's see, sharing window. Now, let's see if it'll let me. Here we go. So ZTF, you guys probably know more about this than I do. Zwicky Transient Facility Sky Survey Telescope. It's up on Mount Palomar. You can see this picture. It's not far from the 200-inch, so it's right in you guys' backyard. By the way, I'm out in the Tucson. I'm actually about 50 miles out of Tucson is where I am, kind of out in a rural area. That's a picture of the scope itself. It is a Schmidt camera, 48-inch aperture. It is robotic. Can you, by the way, see the green file names that I have at the bottom of the pictures?
Yes.
Okay, terrific. I can't because there's actually a little Zoom notification that sits right on top of that for me, but that's okay. As long as you can see it, that's good. So Schmidt camera, it's pretty much, you know, you mentioned an 8-inch Celestron, has a corrector plate up front, a big spherical mirror, this one 4 feet in diameter in the back. It does not have a secondary mirror up here. Can you see my mouse moving around on the picture?
Yes.
Yes.
Great. Okay. It has a camera that sits on a spider vane right about mid telescope, and then some electronics sitting out there. Anyway, enough of that. What's special about this is it's a survey telescope or a survey camera, and it covers a very wide field of view, almost 7 degrees by 7 degrees, almost 49 square degrees in one picture. The sensors individually are 4 by 4 square, and there are 16 of them. Here they are in their little factory packagings, okay? And then what they do is they take them out of this little package and they put them into an array that looks like that, okay? So that thing is almost 15 inches square and allows that telescope to just see a huge chunk of sky and record very detailed photographs down to magnitude 20 in a single shot, and make enough shots that in 3 nights they do the entire northern hemisphere. Well, that's a lot of sky and a lot of data. So that telescope is one of a number of what are called survey telescopes, and these days the survey telescopes are discovering most of the comets. You know, in older times, it used to be astronomers and a lot of amateur astronomers were capturing comets for the first time. But now these robotic telescopes that can make these images night after night are responsible. And in any case, there's different, you may see Atlas here. Well, you've probably heard there's Comet Atlas. Up here you see Pan-STARRS. There's comets that it'll say, you know, 2022 means it was discovered in 2022, and then it'll say Pan-STARRS, it was discovered by the Pan-STARRS survey telescope. In this case, we have a ZTF discovery. And just for grins, you know, we're looking into what is really the purpose. Are these telescopes out there is their primary purpose to discover comets? Well, maybe not exactly. Maybe they have another function. There you go. So hopefully that gives us some good feeling that eyes are looking out for us. So where do you find this telescope? Out among the stars. I've made some little finder charts here. This first one is for tonight at 9 p.m. This is also, I ran the model for Los Angeles, California, so hopefully that's in you guys' area. And the time of this model is 9 p.m., and that's your local time. And what we can see is we're looking north. Here's this green line on the bottom is the horizon. By the way, this comes out of Sky Safari. You probably are familiar with that. It's just a great little app that runs on your phone. North Pole, Polaris. Here's Capella in Auriga, and here's the comet, about 10 degrees just to the lower right. So if you were to go out after the meeting and you had clear sky, you could sweep your binoculars down maybe 3 fields of view and over one, and you might be able to see that guy. How bright is it? It's been about magnitude 5. If you've got dark sky or reasonably dark sky, it is visible as a little fuzz dot with the naked eye. And it would all be good tonight except for this little guy right up here that's about full and making the sky not so dark. That said, though, with binoculars, even with the moonlight, you might have a chance of spotting it if you can get your binoculars in this area. So Ron was asking, so when does it get good? Well, starting next Tuesday at 7 p.m., which is after astronomical dusk. So it's fully dark for the Los Angeles area, 7 p.m. The moon is still below the horizon. It hasn't risen yet. And the comet has now moved about 10 degrees above Capella at that time. So you could use that as a guidepost. It's getting pretty close to overhead. And in fact, on Wednesday, February 8th, it passes within about 1 degree of the zenith. And then just kind of for interest, we were talking about Mars. That little guy's on the move, you know, just went past Earth, just went through the solar system ecliptic plane. So the relative motion to us is looking very large night to night, but it'll cruise past Mars on those 2 nights of the 10th and the 11th. So it could be a good photo opportunity if anybody's looking for a composition there with a comet and Mars. All right, so now the next question is, if we can find it and we can see it, can we take a picture of it? So I'm just going to show you a couple of attempts that I made. The first one, there we go, was done like this. It was done with my cell phone, and actually up at Cow Canyon Saddle, which I learned about through Ron, because a couple of years ago I wanted to do a small outreach activity in the Los Angeles area and was looking for a reasonably dark place that I could reach in not too much time. And Ron set me up and got me access to Cow Canyon Saddle, and it worked out terrifically. And so in fact, I did go up to Cow Canyon Saddle. I was in the Los Angeles area back on the 24th of January, did something like this with my cell phone and got this. It was a 1 second exposure with my cell phone braced on top of a pole, held with my hands. And I don't know how well this comes through, but there's actually a little tiny dot right there at the intersection of my my cursor and the red arrow. And I'm going to blow it up a little bit here for you. That is the result of a 1 second exposure with a cell phone with the ISO cranked up, which it does automatically. And I want to say here too that the cell phones have gotten tremendously smart, especially in the last couple of years, the software for the cameras. If I had had mine a little more securely braced, it would have detected that it was not moving, and it would go into astrophotography mode, and it would take a 60-second exposure, up to 60 seconds. And I couldn't get it to do that. I would have liked to have seen what that would have looked like, but this is all I could get that night. Well, and I got home and I thought, well, I want to try a little something better. So this is a Canon DSLR with 135 millimeter focal length telephoto propped up on an old crate. And I took some 2 second exposures with that camera and lens combination. And that's what that looked like. And I'm gonna see if I can zoom in here just a little bit. I don't know if it's worthwhile. Oh, maybe not. There we go. Anyway, I don't know how much you can see, but I seem to see a couple of faint tails coming out of it, almost in a V pattern right there. And finally, I took some photos through the C14, and this setup has a Hyperstar lens that comes from Starizona in Tucson, Arizona, and the Canon 6D body, same one that I used to shoot that last photo. And some nights ago, I was able to get this photo. This is 9 8-second exposures. That was all I could manage because it was a cloudy night and I was shooting between the clouds. But here it's fairly apparent that we've got some sort of big dust tail over here and some sort of ion tail sticking out this way. Oh, anyway, I think there's going to be a lot more opportunities to see this comet and photograph it if you want to after the 7th. Here I've got a URL for you. If you want the finder charts that were in this presentation, you can go to this. It's just tinyurl.com, and then this is the operative part that you need to put into your browser right here after the slant, this mtdv7527, and that will take you to a folder in the cloud with the finder charts on it. And it'll also have this finder chart right here. This was a German production, so you'll notice Polaris is Polarstern or Stern or something like that. And on the dates, it says 2023 Roman numeral 114, so that is 1 January, and where it says 2, that is not 11, that's 2 February, so we are right about here somewhere tonight. But that's there also for you if you want it. And I think there was one other thing. Oh, that's pretty much it. Okay, so I'm gonna see if I can stop. Have I stopped sharing?
Yes.
Great. All right, there you have it. That's more than I know about that comet.
Hey, thank you.